My name is Alexandra Zakharova, and I am Microsoft Technical Trainer. I have two big passions in life, education and technology. I am delighted to welcome you to Azure Fundamentals. This course comprises 6 sessions. Starting with the first session, Cloud Fundamentals. In the second session, we will delve into Azure Architecture and Azure Compute Services. The third session covers Azure Networking, while the fourth session focuses on Azure Storage. The fifth session discusses Azure Identity, Access and Security, as well as Azure Cost Management. Lastly, in the sixth session, we will explore Azure Governance and Compliance, Azure Resource Management, and Azure Monitoring Services. So, let's get started with the first session.
Let's continue and start with the first session where we'll describe the core principles of cloud technology. Specifically, in our first lesson, we will cover cloud computing, the shared responsibility concept, cloud models, capital expenditure, and operational expenditure. In the second lesson, we will discuss the benefits of cloud technology and conclude the session with a description of various cloud services. If this is your first encounter with the cloud, don't worry, it's going to be great. We'll cover the general terminology of the cloud computing using common terms used by various cloud service providers in the market. Now, let's get to the most crucial part, defining cloud computing and its purpose. Nowadays, almost everyone uses cloud technology. When I say everyone, I mean restaurants, medical center employees, banks, logistic workers, human resources, hairdresser, and so on. Basically, anyone dealing with programs or services over the internet. Even my grandmother recently asked me what I do at Microsoft. And when I told her that I teach cloud technology, to my surprise, she said she knows what cloud is. I asked her to explain, and she said it's where she stores all her photos. So what exactly is cloud computing? Cloud computing is the delivery of computing services over the internet, enabling faster innovation, flexible resource allocation, and cost efficiency. When you leverage the cloud, you essentially rent infrastructure from cloud provider, including compute, networking, and storage resources. To better understand these components, let's draw a parallel with the function of the human body. Computing can be compared to the brain. It's the central processing unit where all operations take place. Networking, on the other hand, can be likened to the circulatory system responsible for the flow of information and communication, similar to our limbs that facilitate movement. Lastly, storage can be seen as a warehouse or a library, acting as a repository for storing and retaining data and information. Much like how our stomach digests and holds nourishment. These resources are hosted in data centers located worldwide, operated by third-party organizations. As a customer, you have access to leverage these tools and capabilities. Gone are the days when owning your own data center was the only option. The cloud provides flexibility and accessibility. It caters to businesses of all sizes, not just large corporations. The cloud offers multiple benefits, including financial advantages and reduced maintenance overhead. By utilizing a cloud provider, you can focus on your core business objectives, instead of dealing with the complexities and costs associated with maintaining your own data center. Let's deep dive the different model of cloud computing. What are cloud models? The cloud models define the deployment type of cloud resources. The three main cloud models are private, public, and hybrid. Let's explore the private cloud. It refers to a single organization having complete control over its infrastructure. This means they are responsible for all the hardware. Only that organization has access to the services and resources provided. As the saying goes, with great power comes greater responsibility. And this holds true in the case of the private cloud. While you have control over your data and can determine who accesses it and how, you can also have the burden of high overhead costs. Additionally, technical expertise is required to handle tasks such as ordering, setting up, and maintaining the infrastructure. In the private cloud, you are accountable for fixing any issues that arise, as there is no panic button to rely on. Despite the challenges, there are benefits to the private cloud. For instance, you don't need a public connection to access your data. You can establish a completely private network for accessing your resources. As the owner of a private cloud, you maintain control over all aspects, from determining who has access to your data to deciding how it's managed. However, it's important to remember that with this control comes the responsibility to address any problems that arise. If you make a comparison, the private cloud can be likened to owning your own car. You have the freedom to manage it according to your needs and preferences. However, it's important to note that owning a car requires maintenance and can be more expensive than using public transportation. Now, many people may think that private and public clouds are completely opposite. However, the truth is that they share many design principles and technologies. Let's delve into the details. A public cloud is like a bus or subway system. It's built, controlled, and maintained by a third-party cloud provider, allowing anyone who wants to purchase cloud services to access and use its resources. Just like public transportation, the public cloud is open to everyone. Users can easily hop on and hop off whenever they need, paying for the distance they traveled based on their specific stops. One of the main advantages of the public cloud is that the users are not responsible for its maintenance. They can simply utilize the services without worrying about infrastructure management or hardware upkeep. It's similar to how passengers on a bus or subway don't have to worry about maintaining the vehicle or the tracks. Another parallel between the public cloud and the public transportation is the ease of access. No significant licenses are required to use the public cloud. Similarly, when boarding a bus, you don't need a specific license to do so. The public cloud allows individuals and organizations to quickly leverage its resources and services without extensive setup requirement. Just as you pay for public transportation based on where you boarded and where you go out. The public cloud operates on a pay-as-you-go model. Users are charged based on their usage, whether it's the amount of storage used, computing resource consumed, or data transferred. So, when thinking about the public cloud, envision a convenient and accessible system, much like taking a bus or subway. It offers flexibility, scalability, and cost-effectiveness for users, enabling them to leverage cloud resources without the burden of infrastructure management or complex requirements. Now, let's discuss the hybrid cloud, which combines the best of both worlds. Think of it as having the option to choose between a bus and a car depending on your needs. The hybrid cloud allows organizations to leverage components of public cloud while maintaining control in the private cloud. For instance, let's consider an accounting firm or a medical office that needs a public-facing website. They can utilize the public cloud to host their servers for the website, ensuring speed and accessibility. At the same time, they can connect that website to a secure database in their private cloud to comply with data governance regulation. The hybrid cloud offers flexibility tailored to different organizational needs and preferences. Keep in mind that every organization has unique requirements, and hybrid cloud provides solutions and flexibility like no other option out there. If we return to our analogy, considering that I live close to Paris, there is often significant traffic in the city center during the morning. Given that I live outside of the city, I have the option to drive to the train station and then utilize public transportation to reach the city center. This involves combination of two approaches, using a private car and relying on the public transportation. As we continue our journey today, we will explore different terms and scenarios where one cloud model may be more beneficial than the other. In the table on my screen, several key aspects of comparing different cloud models are presented. Public cloud saves us money, as we only pay for what we use. All programs and applications are installed quickly. In the private cloud, everything is much more expensive from the beginning because we must buy our own equipment, ensure its security, and not forget about maintenance and updating our applications. Finally, in the hybrid cloud, we have the flexibility, as it allows us to decide where to run applications and how to control security. To remember these three terms for the exam, you can use our analogy with different modes of transportation. Now, turning our attention to cloud models, we have covered a lot of ground. However, a pressing question arises. Alexander, how does the payment structure work? And this is where the cloud truly shines as an outstanding solution. When we delve into cloud expenses, we can approach it from two distinct angles. To illustrate, let's consider a scenario. Imagine my online business involves selling flowers. I'm looking to quick start a website and I'm considering local hosting. In the context of a private cloud model, getting started will entail an upfront investment. I would have to acquire a server rack, cables, wires, and all the essentials to launch. The initial investments can be substantial. However, over time, assuming my demand remains relatively steady, my physical infrastructure cost will taper off. While the upfront expenses might be significant, it's important to remember that this isn't a recurrent monthly cost. The assets are now under my ownership. On the flip side, if my business expands and scaling becomes necessary, I will need to invest further. What I have just described is known as capital expenditure, or a CapEx model. In this model, you front-load your expenses, creating a financial burden. While it's true that you won't encounter additional charges, since you have paid it upfront, you are exposed to the risk of depreciation and obsolescence. Similar to purchasing a laptop today, only for it to be outdated next year, or buying a brand new car that loses values once it leaves this lot. Technology follows a similar trajectory. In contrast, OpEx is spending money on services or products over time. Renting a convention center, leasing a company car, or signing up for cloud services are all examples of OpEx. It operates on the line of operational expenditures. This approach holds immense value, as it supports a pay-as-you-go philosophy. You get what you need right away and are billed only for the products and services you actively utilize. Cloud computing falls under OpEx because cloud computing operates on consumption-based model. With cloud computing, you don't pay for the physical infrastructure, the electricity, the security, or anything else associated with maintaining a data center. Instead, you pay for the IT resources you use. If you don't use any IT resources months, you don't pay for any IT resource. Now let's move on to the various advantages of the cloud. When deploying application, services, or any IT resource, it's essential that these resources are available when needed. High availability is designed to ensure maximum accessibility regardless of possible failures or other events. When developing a solution, it's crucial to consider the services availability guarantees. Azure provides a highly available cloud environment with uptime guarantees based on the specific service. These guarantees are part of the service level agreements, SLAs. Another significant advantage of the cloud computing is the scalability and elasticity of cloud resources. Scalability allows you to adjust resources to meet demand. When sudden traffic spikes and system overload occur, scalability enables the addition of extra resources to efficiently handle the growing demand. Elasticity, on the other hand, allows for automatic scaling. Scalability generally comes in two forms, vertical and horizontal. Vertical scaling involves increasing or decreasing resource capabilities. Horizontal scaling involves adding or removing resources. To explain simply, think of a virtual machine. Let's say I have a virtual machine and it currently has 4 GB of RAM. Based on analytics embedded in Azure, my manager tells me, Alexander, 4 GB are not enough for our current needs. We need to increase its size. So what I do? Well, I scale this machine up to 12 GB of RAM. But guess what? New analytics reports come in and my manager says, Alexander, we went too far, 12 GB are too much, we can save some money if we scale down to 8 GB. And this is the perfect number for our virtual work environment. So I scale it down to 8 GB. Regarding horizontal scaling, let's say for the task I need to perform, one virtual machine isn't enough. I need to have multiple virtual machines running simultaneously. So I will scale to 2 or to 3 virtual machines. It's important to note that I'm using virtual machine memory as an example, but you can scale any other resource in similar manner. As you remember, I have already mentioned that elasticity is the ability to automatically scale your resources. Let's say you have a website for selling children's toys, and you can use automatic scaling to add more storage automatically during holiday period. Similarly, in the event of significant decrease in demand, deployment resources can be scaled down automatically. Let's get back to our advantages. Reliability is the ability to recover a system after failures and to continue operations. It's also a fundamental principle of a well-designed platform. Cloud, with its decentralized structure, naturally supports a reliable and robust infrastructure. Thanks to this decentralized structure, cloud allows resources to be deployed across regions worldwide. With such a global scale, even if one region experiences catastrophic events, other regions continue to operate without disruption. You can design applications to automatically leverage this enhanced reliability. In some cases, the cloud environment itself will be automatically moved to another region without any action required from your side. In this training, we will further discuss how Azure utilizes global scaling to ensure reliability. The next advantages of the cloud is predictability. Predictability in the cloud enables you to confidently move forward. Predictability is mainly focused on forecasting performance or cost. Performance predictability involves forecasting the resources needs to ensure the most efficient conditions for customer operations. Automatic scaling, load balancing, and high availability are just some of the cloud concepts that ensure performance predictability. If you suddenly need additional resources, elasticity allows you to deploy additional resources to meet demand and then scale down when demand decreases. Or if traffic is heavily focused on one area, load balancing allows redirecting some overload to less burdened areas. Cost predictability is about forecasting cloud expenses. Through the cloud, you can track resources usage in the real time, monitor resources to ensure their most efficient utilization, and apply data analytics to identify patterns and trends that help better plan resource deployment. The sixth characteristic of the cloud is security. Cloud offers robust security measures, including data encryption, identity and access management, and continuous threat monitoring. Leveraging cloud allows organizations to tap into the expertise and resources of established providers, enhancing their ability to fend off cyber threats and adhere to industry compliance standards. Azure's advanced security features, regular updates, and dedicated security teams help safeguard sensitive data and application, providing businesses with a strong foundation to mitigate risk and maintain a secure online environment. The 7 advantages is about cloud features supporting governance and compliance requirements. Cloud capabilities, such as predefined templates, guarantee that all deployed resources adhere to corporate standards and government regulations. Additionally, you can update all deployed resources according to new standards as they arise. Depending on your operational model, software patches and updates can also be applied automatically, simplifying management and ensuring security. And finally, the 8th advantages of cloud computing is manageability. Cloud management means managing cloud resources. In the cloud, you can perform various actions such as deploying resources based on pre-configured templates, eliminating the needs of manual setup, tracking resources health, and automatically replacing faulty resources, as well as receiving automatic alerts based on configured metrics to monitor real-time performance. Moreover, the cloud offers the various management methods that we'll discuss shortly. Now, let's explore the different types of cloud services and describe some use cases and benefits associated with each service. First of all, infrastructure as a service, IaaS, is the most flexible category of cloud services as it provides maximum control over cloud resources. In the IaaS model, the cloud service provider takes care of maintaining the hardware, network connectivity to the internet, and physical security. You're responsible for everything else, including installing, configuring, and maintaining the operating system, network settings, databases, storage, and more. With IaaS, you essentially rent the equipment in the cloud data center, but have full control over how to use that equipment. Platform as a Service, or PaaS, is the comprehensive cloud development and deployment environment with resources that enable the delivery of a wide range of cloud applications, from simple to sophisticated solutions. Similar to IaaS, PaaS includes infrastructure, server, storage, and network equipment, as well as the middleware, development tools, business analytics BI, database management services, and more. PaaS is designed to support the entire life cycle of a web application: development, testing, deployment, management, and updates. In PaaS scenario, you don't need to worry about licensing or installing patches for operating systems and databases. PaaS is a great choice for providing a fully functional development environment without the need to manage all the development infrastructure. And the third, Software as a Service, or SaaS, is the most complete cloud service model from a product perspective. With SaaS, you essentially rent or use a fully developed application. Common examples of SaaS implementation includes email services, financial management software, messaging application, and connectivity software. While the SaaS model may be the least flexible, it also offers the easiest way to get started. It requires minimal technical knowledge or experience for full utilization. Let's delve into a comparison of these 3 distinct cloud service types. Infrastructure as a service is like renting computer equipment from the cloud. You get to control how you use it, such as setting up different virtual machines for various tasks. Platform as a service, on the other hand, often finds application in software development. Here, the cloud service provider takes charge of platform management. For instance, you might utilize PaaS to build a web application without need to worry about underlying infrastructure. Moving to software as a service, this entails receiving a fully functional application ready for use. Think of it like accessing an email service or a collaboration tool such as Outlook, Salesforce, or MailChimp, where users pay based on a subscription model for the software they utilize. The shared responsibility model applies to all types of cloud services. The diagram you see on the screen illustrates different levels of responsibility depending on whether you use cloud services like IaaS, PaaS, and SaaS, or manage your own on-premises data center. Let's start with the right side of the diagram, which represents your on-premises network. Here, you're entirely responsible for everything, starting from the physical infrastructure. You're also responsible for your operating system, application, managing all users, and ultimately your data. However, as you transition to the cloud, the responsibility is shared between you and your cloud provider. In IaaS level, you rely on Microsoft for supporting the physical infrastructure. Microsoft also takes responsibility for its security, but you're responsible for everything that is not part of this physical infrastructure. Then you move to PaaS, you no longer need to worry about the underlying operating system. Microsoft takes care of securing the operational system and some other management elements such as networking and application support, but you still need to contribute. This includes securing your applications and managing those who have access to your data. SaaS is a model where the cloud service provider takes the highest responsibility and the user has the minimal responsibility. In a SaaS environment, you're responsible for the data you add to the system, the devices you allow to connect to the system, and the users you grant access. Practically, everything else falls under the cloud service provider's responsibility. They're responsible for the physical security of a data center, power, network connectivity, application development, and software updates. What I want you to take away from this table for your understanding is that your level of responsibility will vary depending on whether you use cloud services or set up equipment on premises. Additionally, you always take responsibility for your users' devices and data. Now, let's find an analogy from real life and talk about pizza. Yes, pizza. Our on-premises system is like making pizza at home, where you are responsible for all the ingredients, the table, cooking, etc. Yes, it's like ordering groceries to your house and make the pizza. PaaS is like pizza delivery, where we receive the pizza in a box at home, but we still need to set the table, get drinks, and clean up. And SaaS is like going to a pizza restaurant where the table is already set, food and drinks are ready, and they will even clean up after us. I hope this delicious analogy helps you better remember the shared responsibility model.
Now, let's recap what we covered in this session. We discussed the definition of cloud computing and cloud deployment models, where we compared private, public, and hybrid clouds to different transportation types. We also talked about the differences between capital and operational expenditures, defining that cloud technologies leverage operational expenses. Furthermore, we discussed the 8 key advantages of the cloud. Then, we explored different types of cloud services and drew an analogy with pizza. With that, our first session comes to an end. Thank you for your time. Welcome to the second session, Azure Architecture and Azure Compute Services. In this session, we will discuss the architectural components of Azure. We will learn about the physical organization of Azure, including data centers, availability zones, and regions. We will also explore the organizational structure of Azure, such as resource and resource groups, subscriptions, and management groups. Towards the end of the session, we'll delve into various compute services available in Azure.
So let's begin with the initial lesson, centered around the fundamental components of the architecture. This happens to be my favorite lesson due to my passion for travel. I will demonstrate you how Azure empowers you and your data to traverse the globe, enabling resources to find their place in any corner of the world. A region is a geographical area that contains at least one data center or multiple data centers located nearby and interconnected with low latency networking. The Azure platform automatically allocates and manages resources within each region, ensuring proper load balancing. When deploying a resource in Azure, you often need to select a region where it should be deployed. Certain services or virtual machine types may only be available in specific regions. Additionally, there are global Azure services that don't require choosing a specific region, such as Microsoft Entra ID, Azure Traffic Manager, and Azure DNS. Microsoft Azure currently comprises more than 60 regions worldwide, available in 140 countries. The second term related to our regions is availability zones. Availability zones are physically separated data centers within a single Azure region. Each availability zone consists of one or more data centers equipped with independent power, cooling, and networking systems. As a result, an availability zone acts as an isolation boundary. If one zone experiences an outage, the others continue functioning. Availability zones are connected through private, high-speed fiber optic networks. To ensure resilience, each region supporting availability zones has at least 3 separate availability zones. However, some services may have limited support for availability zones. For example, some may only support availability zones for certain tiers, regions, or SKUs. Another crucial point to note is that most Azure regions are paired with another region within the same geographical area with a separation of at least 482 kilometers or 300 miles between them. This strategy enables the replication of resources across geographical zones, minimizing the risk of disruption caused by natural disasters, extensive outage, power failures, or network issues affecting an entire region. For instance, if one region from a pair is impacted by a natural disaster, services will automatically switch over to the other region in this pairing. Some examples of Azure region pairs include West US and East US, as well as Southeast Asia and East Asia, among others as mentioned on the slide. Since region pairs are directly connected and adequately distant from each other, they can be utilized to ensure redundant and reliable services and data. Besides the regular regions, Azure also offers sovereign independent regions for government organization. In other words, sovereign and independent regions are Azure regions dedicated to government entities, isolated from the main Azure environment. Azure government regions in the United States are physically and logically isolated from Azure networks for US government agencies and their partners. These data centers are operated by US citizens and undergo additional compliance checks. Azure government utilizes the same underlying technologies as Azure. This includes the services as IaaS, PaaS, and SaaS. Both Azure and Azure Government provide comprehensive security management capabilities and upload Microsoft data protection commitments. Azure China represents a distinct sovereign region constituting an isolated Azure environment within China's borders. This exclusive Azure sovereign region in China is established through special collaboration between Microsoft and 21 ViaNet. Unlike other Azure regions, Microsoft doesn't directly oversee the operation of data centers here. Instead, 21 ViaNet autonomously manages this region. Now, let's proceed with the demo to explore our architectural landscape within the context of our global reach. Welcome to our first demo. In this demo, we will discover together Azure Global Infrastructure. For it, I will use the following website that you can see on my screen, so you can also discover it whatever and whenever you want. I will load the page and it will open me the global infrastructure experience. So what I have here, I have a 3D map of our globe that I can turn to discover different regions and geographies, as well as I have news updates related to our data centers and the legend on the left. If I open the legend, I will see different explanation of all symbols on my map. So, for example, this blue round, it's regions. I have also a square for zones, and even I have different sustainability projects for wind, solar, or mixed type of energy. And as well, I can open the filters to see my region according to different compliance measure or industry compliance. As well as I can discover different disaster recovery options available in each region. So if I close my legend and filters, I can turn the globe and to start seeing what are the different options available. For example, I have Central US, where I will see that this is a region with availability zones. Also, its location will be indicated as the year of opening and different products available in this region. So if I want to know more, I can just click on those options and to discover the details. For each region, I also have the data residency. So I will know that everything is stored in the United States. I will know that I have availability zones with 3 zones available and also different disaster recovery options as cross-region disaster recovery and in-region disaster recovery. Moreover, I even have sustainability as there is a Microsoft Circular Center coming soon. And at the end of the description, I will find different compliance standards and industry standards. So I can view them and to check that everything corresponds to my compliance needs. And also there is a link that helps me to learn about Azure compliance more in details. So it was Central US. What if we look in the center of Europe? So you know that I'm based in France. And here we are. So location is in Paris. For sure, I will not find the detailed location as each region is highly secured. Also see the year of opening, different products available, and again, availability zone, disaster recovery, and compliance. If I look on my globe, we will see that Azure is huge service because we can find it in every corner of the planet. Even here in New Zealand, we can check that soon we will have one region that is coming and also related articles to it. What I have as well here is the possibility to switch to the map view or to come back to my 3D globe. And we have a new feature that was added, that it's a virtual tour of a Microsoft data center that you can also take from this website. So hopefully you enjoy it and you will reuse the provided link in the future to discover more information about Microsoft data centers available to you. A resource is a basic standard building block, meaning any component in Azure, everything you create, provision, deploy, etc. is a resource. Virtual machine, virtual networks, databases, cognitive services, etc. All of them are resources in Azure. We'll talk about each of those things in more details on the next slides of the session. For now, I won't explain each one in details, but I will come back to that later when we discuss their meanings. Resource groups are simply resource grouped together. As the name suggests, when creating a resource, you need to place it in a resource group. While a resource group can contain multiple resources, each resource can be only reside in one resource group at a time. Some resources can be moved between resource groups, but when moved, they will no longer be associated with the original group. Additionally, resource groups cannot be nested, meaning you can't place resource group B within resource group A, and we can't create a hierarchy between them. Resource groups offer a convenient way to group resources because actions applied to a resource group apply to all resources within it. Deleting a resource group will remove all resourcing within it. By granting or denying access to a resource group, you are effectively granting or denying access to all resources within that group. When preparing resources, it's recommended to carefully plan the resource group structure that best suits your needs. For example, if you are setting up a temporary development environment, grouping all resources allows you to undo the setup all related resources simultaneously by deleting the resource group. If you need to set up 3 different ways to access the compute resources, you are creating 3 different resource groups. It's a good idea to organize the resources by each access method and then manage access at the level of these grouped resources. Now, let's examine the management structure that contains our resource groups. To do that, we'll proceed to subscriptions. Subscriptions are the unit of management, billing, and scaling in Azure. Similar to how resource groups are a way of logically organizing resources, an account can have multiple subscriptions, but only requires one. In an account with multiple subscriptions, you can use subscription to configure different billing models and apply various access management policies. Azure subscriptions can be used to define boundaries for Azure products, services, and resources. Subscription boundaries come into 2 types: billing boundaries and access management boundaries. The billing boundary of a subscription determines how charges for use in Azure in the account are applied. You can create multiple subscriptions for different billing requirements. Azure generates separate billing reports and invoices for each subscription to help you organize and manage expenses. Additionally, Azure applies access management policies at the subscription level. You can create individual subscriptions that align with your organization structure. For example, within a company, specific departments could have separate Azure subscription policies. This billing model allows you to control access to resources used by users within their respective subscriptions. So, when thinking about subscription, remember that they serve as billing boundaries and regulate access. The last architectural element I want to discuss with you is management groups. As you already understand, resources are grouped into resource group, and resource groups are further organized into subscriptions. If you're just starting with Azure, this hierarchy might seem sufficient for organizing things. However, imagine you're working with multiple applications, several development teams in different geographical regions. With many subscriptions, an effective approach is needed to manage access, policies, and compliance. Azure management groups offer high-level coverage over subscription. You group subscriptions into containers called management groups and apply governance conditions to them. all subscriptions within a management group automatically inherit the conditions applied to the management group, similar to how resource groups inherit settings from subscriptions and resource inherit settings from resource group. Management groups provide enterprise-level management at large scales, regardless of subscriptions type. Resource groups can be nested within management groups. Important fact about management groups: one directory can support up to an incredible 10,000 management groups. Also, a crucial fact is that the management group tree can support up to 6 levels of depth. This limitation doesn't include the root level or the subscription level. Within this tree, each management group and subscription can have only one parent element. To better understand the structure, let's see how we can create a resource on the portal. Welcome to our second demo. In this demo, finally, we will see Azure portal. I would like to show you how to create a resource, and for this example, I will use virtual machine creation. To create the EVM, I can use multiple possibilities. I can search it here, or I can use my menu on the left, or I can just select recently used resource that is virtual machines. I will open it, and as for any resource in Azure, I have a button with a plus to create my resource. So I will create a VM together. When I'm starting a creation of any resource, I will have a project details that will be asked, involving subscription name and resource groups. So I will select my existing subscription, and after that I can create a new resource group for this demonstration. We can call it AZ-900 demo. After that we selected our resource group name, we can name our virtual machine. Also, we'll keep the same name for demonstration purpose, but if you're having doubts how to name your resources or what each field means, you can read the information provided in small boxes related to each resource. So no worries, Microsoft always helps you to learn more. So also sometimes we'll provide you the link that will bring you to Microsoft Learn if you're having doubts what is asked to fill inside. After I will select my region, I will use North Europe for example, because I'm based in France and I prefer always to use the region close to me and my user for the latency purpose. After that we have availability zones. As we mentioned before, we can have 3 availability zones, as well as I have 2 extra availability options, virtual machine scale sets and availability sets, that we'll discuss just later in this session. For the demo, I will not create extra availability options because we'll just see how to create a resource. After that, I have an image proposed here. I can use or recently used one, or recommended one, or even I can see all images accessible to me inside of Marketplace. So here I have powerful filters to search and select different VM, Windows or Linux one with different characteristics. For my case, I will just take a suggested one, and after that I will decide the size of it. The size will impact the cost, as you can see from the different proposed fields. I will go with the cheapest one for this purpose, and no worries, we'll come back again today regarding our sizes, so we'll discuss it again during our training. After that I can create a username. I will use Contoso for example, and I will need to provide a secret password for it. And after that we can select different ports. Opening, we'll discuss it more in details during our networking session. For the creation I will select just HTTPS. And no worries, if you forget to fill information about the ports, you can correct it later and we'll see how together in the next session. Also, I can provides information about the disks. I can select network that I would like to use. Also, you can see that it's creating automatically a new one for me. After that, we have management opportunities with information about the security features, monitoring one with alerts and diagnostics, advanced feature if you need some VM extensions or applications to use, and finally tags that are accessible to all Azure resources. And if I didn't specify all details about each field, it's because we'll speak about networking and monitoring and tags more in details during our training. Now it's just to show you how we can create a resource. And in the end, we have review and create, and we'll have a final validation of our resource creation. So if I forget something or I didn't provide the correct information, I will have a pop-up window saying like I did a mistake and I need to come back and verify it. Also, I will see at the end my final price. So we will pay just for what we use. It's a consumption-based model. And I see the price for each hour. So I know how much I will need to spend for this specific VM after I created it. I can review the full information I provided to verify that I have everything filled out correctly and click on create and we'll see what will happen. As I click on create, I also have a pop-up window saying the deployment started, and after that the deployment in progress will appear. And here you'll see the list of resources that will be created, their type and status. And what is the magic about creation of VM? And the fact that while we create a VM, we're also automatically creating multiple resources that just appear here. And after that, it will take approximately 1 minute to wait until everything is created and we can access our resource. Wonderful, as you can see, our VM is created. I can go to our resource and here we are. We have all information about our VM provided. You can also modify the settings on the left side, or we can review a resource group where we have our VM. If I go to our resource group, I will see that we created so multiple resources via one resource creation. So I started the virtual machine creation, but also during this process I created my resource group, public IP address, network security group, VNet, network interfaces and disk. And all these elements we'll discuss during our training. No worries, but it's just to show you the power of the cloud and the power of resource creation. As I created one resource, I added multiple during one task inside. Now, as we discover the portal, it was our first step in our learning of the Azure portal, let's come back to our presentation. Let's now explore different types of Azure computing. In this section, we will get to know Azure computing services. We'll explore different choices for computing, like virtual machines, app services, containers, and virtual desktops, which are displayed on the screen. We'll look at each of these resources separately in this session. So let's begin with the virtual machines, which we'll saw in our previous demonstration. With Azure Virtual Machines, you can create and use virtual machines in the cloud. They provide infrastructure as a service in the form of virtualized servers, and you can use them in various ways. Just like on a physical computer, you can configure any software running on a virtual machine. Azure Virtual Machines are an ideal choice if you need full control over the operating system, the ability to run custom software, and the integration of customizable deployment configuration. Azure Virtual Machines offer flexible virtualization capabilities without the need to purchase and maintain the physical hardware on which they run. However, within the IaaS offering, you still need to handle the setup, updates, and maintenance of the software running on the virtual machine. Virtual machines also have various capabilities that I briefly mentioned during our virtual machine creation, such as scale sets and availability sets. Virtual machine scale sets enable you to form sets of identical virtual machines while incorporating load balancing and management capabilities. Why might you opt for virtual machine scale sets? Primarily, they offer redundancy and enhanced performance. Applications often require distribution across multiple instances for reliability. As your application communicates through a load balancer, it distributes requests to various application instances. During maintenance or updates of one instance, the load balancer shifts customer requests to available instances, ensuring continuous services. For handling increased customer demand, you might need to scale up the number of application instances running your software. Azure Virtual Machine Scale Sets provide this essential management capability. They seamlessly manage applications spanning numerous virtual machines, automatically adjusting resource allocation and evenly distributing traffic. The advantages are apparent. Firstly, they're effortlessly created and managed, even for multiple virtual machines. Secondly, they offer high-tended availability and application resilience. Thirdly, they enable your application to adapt as resource needs fluctuate. Lastly, they're equipped to handle substantial scales, with some sets accommodating up to 1,000 virtual machine instances. And finally, virtual machine availability sets are another means to create a more resilient and highly available environment. Availability sets ensure that virtual machines are placed in groups that follow specific update and fault domains, preventing the loss of all virtual machines during a network or power failure. Availability set achieves this by grouping virtual machines in one or two ways: update domain and fault domain. The update domain contains virtual machines that can be rebooted simultaneously. This allows you to apply updates knowing that only a few updates domain grouping cannot be in maintenance mode simultaneously. All machines in one update domain will be updated. And the second element is the fault domain. The fault domain groups virtual machines based on a common power source and network switch. By default, availability sets split virtual machines into 3 fault domains. So even if power or network fails in one domain, others stay safe. This method is cost-effective too. You pay only for the virtual machines you use. Now let's go back to the portal to learn how to set up a virtual machine scale set. In our third demo, we will see how to create virtual machine scale set and use it. So to create it, I can search or select a recent service that I use. If I use my search, I can also review the documentation provided. It's a very practical option because each documentation will bring me to the information how to use this feature, and it will bring me to the Microsoft Learn website. So if I would like to create, I will select virtual machine scale set. Again, as we did with the resource creation of our VM, we can click on plus create and provide the information as before about subscription resource group. This time I will select the resource groups that we created in our previous demo. I will also provide a name. So I will again AZ-900 demo. I will keep it in the same region close to me. Also very practical. I can integrate my virtual machine scale set with different availability zones provided here. And after that, I can select different orchestration mode, flexible or uniform. As for VMs, I have different security types provided. I will go with default one. and I can select an image. You remember during the VM creation I go with Windows, now I will select the Linux one. We will select the sizes. Again, when I select the size, I have information about the price. And after that, we can decide how we will use this virtual machine scale set and how we will protect it. Is it password or the public key? I can, for example, go with the password. I will use the same one, Contoso, provide a secure password, make attention that I remember it, and they're the same. And after that, we'll have multiple options as we had before for our VM. What is the most interesting for me? It's the possibility of scaling that we discussed. We spoke about different benefits, about elasticity, the automatical scaling, and about scaling itself as the benefit of cloud computing. And here we have very interesting flexibility, let's say, because we can decide how many instances we would like to have at the beginning, and if we would like to scale manually or automatically. For automatical scaling, we can select custom option and decide that, for example, I don't want that I have less than 2 instances running, and the maximum number will be 9. And after that, I will select my rules. So I can say if the CPU going more than 75%, for 10 minutes, I will increase my initial count, so my 2 instances, by 1. So we'll have 3. If I have, for example, my CPU going for 75% for 20 minutes, it means I will have plus 2 instances, so it will be 4. And also I can scale in. If, for example, my CPU is less than 25%, I can decrease my instances and have 1. So this way I also save my cost because I don't using so many resources if I don't need them. So by activating it, it's very practical. Let's say if we have Christmas or you have like a Black Friday and you have too many visitors coming, so you can automatically increase your workload, as if you don't have so many customers, for example, Monday, you can decrease your workload. It's how we can set up this automatical scaling. And after that, if you go, we can review different policies, protection, advanced settings, and at the end tags. I'm not showing all these options because we will discuss them later today. So the most important, we saw how we can set up virtual machine scale set and how we can scale it automatically. And after that, we just need to create it and wait until our virtual machine scale set is created. And no worry, you can always adjust your scaling options. So it means after the creation, I can also come back to manual scaling, as I can modify the policy that I created for it. So I can modify and decide, for example, to set up 10 instances as a maximum and 1 as a minimum, and etc. Thank you for your attention. In this demo, I will not wait until it's created because we already saw what is going on. And we can come back directly to our slide as we saw together how we can deploy a virtual machine scale set and also to use automatical scaling inside. Thank you for your attention. Let's go back to the slide. Azure Virtual Desktop is a virtualization service for desktop systems and applications that operates in the cloud. It allows you to use a cloud-hosted version of Windows from any location. Azure Virtual Desktop works on various devices and operating systems, and it's compatible with applications that can access remote desktop or most modern web browsers. Azure Virtual Desktop provides centralized management of user desktop security. You can enable multi-factor authentication to secure user logins. Additionally, you can protect data access with detailed role-based access controls. When using Azure Virtual Desktop, data and application are isolated from local hardware. In fact, the desktop and application run in the cloud, reducing the risk of sensitive data remaining on personal devices. Moreover, user sessions are isolated in single or multi-session environments. When it comes to virtual machines, they are a smart choice for cost saving as they eliminate the need for physical hardware investment. However, they do have a limitation. Each virtual machine can only run a single operating system. Containers, on the other hand, offer an excellent solution when you require multiple instances of an application to operate on a single host computer. The Azure Container Instances service offers the easiest method to run containers within Azure, all without the complexities of managing virtual machines or utilizing additional services. The service falls under the platform as a service model. With Azure Container Instances, you can deploy your containers and the service will take care of launching them. The second key element on this slide introduces Azure Container Apps, a fully managed environment tailored for running microservices and containerized application on a serverless platform. This platform enables the execution of application code packet into any container, and it remains open-minded about the runtime or programming model you choose. With container apps, you harness the benefits of running containers while shedding the burdens of managing complex cloud infrastructure and container orchestration services. Lastly, the Azure Kubernetes Service, AKS, stands out as the quickest route to initiate the development and deployment of purely cloud-native applications, offering built-in pipelines that take you from code to the cloud and comprehensive security features. Azure Kubernetes Service streamlines the deployment of a managed Kubernetes cluster within Azure, elevating the operational responsibilities and shifting them to Azure. This service manages vital tasks, including health monitoring and maintenance. Quite a bit of new information, isn't it? Let's do a quick recap and compare the compute options. In the case of a virtual machine, we have a cloud server supporting Windows or Linux. A virtual desktop provides capabilities for a Windows Cloud desktop. Containers, on the other hand, offer an environment for running microservices. As for their usage purpose, virtual machines are typically used when migrating to the cloud, virtual desktop for connecting user to desktop application, and containers for scalability. Each service has its interesting advantages. Virtual machines include full operating system package. Virtual desktop can support multiple users simultaneously, while containers can reside on one operating system of the virtual machine server. If you need to deploy an application in Azure, you can first consider virtual machines or containers. Both virtual machines and containers offer excellent solutions for deployment. Virtual machines provide maximum control over the hosting environment and precise configuration. They can also be the most familiar way to deploy if you're just starting with the cloud. Containers, with their isolation capabilities and individual management of different aspects of the deployment, can also be a reliable and efficient option. It enables automatic deployment from GitHub, Azure DevOps, and any Git repository to support continuous development. Good, we have covered containers and virtual machine. Now, what about application deployment? Azure Functions are event-driven serverless compute resources that don't require the management of virtual machine or containers. When building an application using virtual machine and containers, these resources must be running for the application to work. With Azure Function, an event triggers the function, reducing the time to prepare resources when there are no events. Azure Functions are suitable when you care only about the code for the service, not the underlying platform or infrastructure. They are used when a simple and fast action, which completes in a few seconds or even less, needs to be performed in response to an event, such as a REST request, timer, or message from another Azure service. Azure Functions automatically scale on demand, making them ideal for cases where requirements change. The Azure Function Service executes code when triggered and automatically deallocates resources after the function's execution. Azure App Service provides a dependable hosting solution for deploying applications within Azure. It allows you to concentrate on constructing and upholding your application, while Azure handles the availability of the underlying environment. Functioning on an HTTP-based model, Azure App Service serves as a platform for hosting web applications, RESTful API interfaces, and mobile backends. This service boasts multilingual support encompassing .NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. Additionally, it accommodates both Windows and Linux environments. Notably, App Service introduces the capabilities of Microsoft Azure into your applications, including security features, load balancing, automatic scanning, and automated management. Beyond that, it extends its offering to DevOps functionalities such as continuous deployment from platforms like Azure DevOps, GitHub, Docker Hub, and other sources. App Service delivers a spectrum of features, including package management, staging environments, and custom domains. These resources are dictated by the App Service plan under which your apps operate. We have reached the end of our second session. Let's recap what we have covered.
We started by exploring regions and availability zones, followed by a deep dive into resources, resource groups, subscriptions, and management groups. We then delved into various options for virtual machines, including the machines themselves, the scale sets, and availability sets. Furthermore, we compared different types of compute services, such as container instances, virtual machines, and virtual desktops. Finally, we discussed services for application deployment. With that, we conclude our second session. Thank you for your attentive participation. Welcome to the third session. In our third session, we will discuss virtual networks. We'll cover the following topics: the purpose of Azure Virtual Networks and Azure Virtual Subnets, VPN gateway, ExpressRoute, and finish with Azure DNS. Let's get started with our third session.
So let's begin our dedicated networking session. Azure Virtual Networks and Subnets facilitate seamless communication among Azure resources, including virtual machines, web applications, and databases. This architecture also fosters connectivity with users across the Internet and local client computers. These virtual networks can be visualized as extensions of your on-premises network, interconnecting various Azure resources. Moreover, in the context of networking within Azure, network peering is a significant feature. Network peering enables the linking of different virtual networks, creating a private connection for communication between them. This connection is similar to a local network extension across virtual spaces. By establishing network peering, you can seamlessly share resources, such as virtual machines or databases, across distinct virtual networks, ensuring efficient and secure communication. Within Azure Virtual Networks, two types of endpoints play crucial roles in data exchange: public and private. Public endpoints possess public IP addresses, accessible from anywhere globally. Private endpoints, however, are confined within the virtual network and are assigned private IP addresses within the virtual network's IP address space. When configuring an Azure Virtual Network, a private IP address range is defined, utilizing either public or private IP address ranges. This IP address range remains confined within the virtual network and lacks internet routing capabilities. Further division of this IP addresses range into subnets allows specific portion of the range to be allocated to distinct subnets. For enhanced security and control, Azure Virtual Networks incorporate network security groups. These groups act as containers for numerous security rules governing inbound and outbound traffic. By evaluating factors such as source and destination IP addresses, ports, and protocols, these rules dictate whether to permit or deny traffic. This fine-grained control ensures the traffic flows as intended, bolstering the network's overall security posture. As we delve into the specifics of Azure's networking capabilities, let's also explore the practical implementation of network security groups within the Azure portal. Welcome to our demo. In this demo, we will review the network access. For this, let's go to the resource group that we created in our VM creation demo. So here in my resource group, I have network security groups that were created automatically. If I will open them, we will see different inbound and outbound security rules. Inside of inbound security rules, we have 3 rules that were created by default and one that was created because I decided to open HTTPS protocol. Also, I have outbound security rules that were added automatically. If you look on these rules, we have a priority. After that, we have a name. For example, allow VNet inbound traffic. We have a port from any port. We have also any protocol, source virtual network, and destination virtual network allow. So it means that the traffic from VNet to VNet is allowed by default. The same we have for outbound traffic that will allow from VNet to VNet, and here we have allow. So those rules were created by default, and one with priority 300 were added because I decided on creation to open HTTPS protocol, and it has priority 300. So less the priority, less the number is higher, more priority we have. So it means if I will create another rule with 200 as a priority number, it will be more important than the rule with the number 300. Don't forget it for exam. Lower is our number, higher is priority. Now, if we would like to connect to RDP with our VM tool, so if you would like to open our remote desktop, it will be very difficult and impossible because we don't have a specific port open. So let's see what will happen if I will decide to connect and how we can create this connection. For it, I will go to our VM, I will select connect, and I will download it an RDP file for the connection. Okay, now let's open our RDP file and select the connection. And you see it's asked if I would like to connect. As the protocol is not open, I should have refused. So let's try and we will see that it will not work. So we see that we have an error message because the access is not enabled. To give an access, what we'll do, we will create a new security rule inside of our NSG's rules. So I'll come back and we will add an extra inbound rule. And we'll decide that this time we will use our RDP protocol. So the service RDP, we will allow the traffic. And if we want to have the biggest priority, we will put, for example, another number, or we can keep it 310. And after that, add this protocol. For sure, I will have a message saying like, this port opened my access to the internet. I also have this highlight symbol because it's important to notify me that I'm giving access to VM over the public internet. So let's come back now to our VM and to try to connect this time as we open the protocol. We will come back again. We will need to download again our RDP file. We'll open our file and we will connect to our remote desktop protocol. I use a Contoso and I provided the password. And after that, again, it will ask me if I'm okay to connect. And here we have a magic. I can open my remote desktop protocol with my Contoso name. And now we learn that we can use the network security rules to open different ports and to have access to our remote desktop and to connect to it thanks to our VM creation and also different network security rules that we added together. Thank you for your attention. Let's come back now to our presentation. Imagine living in a glass house where everyone can see what you're doing. Not a great feeling, right? Well, using the internet without a secure VPN is a bit like that. So what is a VPN? A VPN, or virtual private network, is like a secret tunnel on the internet. It keeps your online information private and safe. It's like putting special tinted glass on your glass house. You can see out, but no one can see in. When you use a VPN, your data travels through this secure passage to special VPN servers. No one, not even your internet service provider or government, can snoop on your data. The VPN also masks your real device's addresses and uses its own address instead. This provides a shield for internet use, even on Wi-Fi networks. A VPN works somehow like building a secret road inside another road. It's useful for linking private networks over the big public internet. Any data sent on the secret road is locked up with encryption, a protective layer that keeps your information secure. Every network can only have one special entry point for this secret road, but this entry point can connect to various places like other networks or your computers located in different spots. In Azure, there exist dedicated VPN gateways. These gateways ensure that data can move securely between Azure networks and your own computers, even when they're far apart. These gateways also enable different Azure networks to communicate securely with one another. In essence, a VPN is your personal, concealed pathway on the internet, ensuring your online activities remain private and secure, much like the walls of a glass house fitted with tinted windows. ExpressRoute is an Azure service that allows you to create private connections between Microsoft data centers and your on-premises infrastructure. ExpressRoute connections do not go through the public internet, providing enhanced security, reliability, and low latency performance compared to regular internet connections. This means as well that ExpressRoute connections offer greater security, reliability, and speed with reduced and predictable latencies compared to standard internet connections. In some cases, using ExpressRoute for data transfer between on-premises devices and Azure can significantly reduce costs. ExpressRoute enables connection to Microsoft Cloud services, such as Microsoft Azure and Microsoft 365, and connects offices, data centers, or other locations to the Microsoft Cloud. Each location has its own ExpressRoute service. You can enable ExpressRoute global reach to facilitate data exchange between on-premises sites by connecting them through your ExpressRoute circuits. For example, if you have an office in Asia and a data center in Europe, both connected to Microsoft's networks through ExpressRoute, you can use ExpressRoute Global Reach to connect these two locations so they can exchange data without going through the public internet. In summary, the main difference between a VPN gateway and ExpressRoute lies in the nature of the connection and the level of performance and security they offer. A VPN gateway uses the public internet to create secure connections, while ExpressRoute provides a dedicated private connection with higher performance and security features. The choice between these options depends on your specific networking requirements, data sensitivity, and performance needs. Moving forward from discussing the difference between VPN gateways and ExpressRoute, let's now explore the capabilities of Azure DNS. DNS, or Domain Name System, can be described as a phone book. It's translating human-readable names to computer-friendly addresses. Azure DNS, or Azure Domain Name System, is a hosting service for DNS domains that provides name resolution by using Microsoft Azure infrastructure. Azure DNS operates as a cloud-based solution, offering the ability to host and manage DNS domains, also known as DNS zones. These zones serve as collections of DNS records that handle the translation of human-readable domain names into machine-friendly IP addresses. By entrusting your domain to Azure's infrastructure, you gain the convenience of overseeing your DNS records using familiar Azure tools, APIs, and credentials. The payment structure mirrors other Azure services, where you are billed based on your usage. Azure DNS seamlessly integrates with your Azure resources, facilitating automated updates to DNS records based on changes within Azure, such as deployment or modifications to resources. When you relocate a web application to a different location, the associated Azure DNS record is automatically adjusted to reflect the change. In Azure DNS, a global network of Azure DNS serves hosts DNS domains. This architecture ensures both resilience and high availability. To optimize query processing, speed, and availability for your domain, the network is designed so that each DNS request is directed to the nearest available DNS server. In summary, Azure DNS provides a dynamic platform for hosting and managing DNS domains. It leverages the convenience of Azure's ecosystem, the efficiency of automation, and the assurance of high availability, contributing to a smoother and more reliable online experience for your users.
In the third session, we focused on Azure Virtual Networks, Azure Virtual Subnets, VPN, ExpressRoute, and Azure DNS. This concludes the third session. We will start our first session where we'll discuss Azure Storage Account and how to compare Azure storage services such as containers, files, and disks, as well as how to describe storage tiers and redundancy options. Let's get started with our fourth session.
And now let's dive into our data storage, starting with storage accounts. A storage account provides unique namespace for data in Azure Storage Services, accessible from anywhere in the world via HTTP or HTTPS protocols. Azure Storage Account contains all data objects of Azure Storage Services, large binary objects or blobs, files, queues, and tables. Data in a storage account is protected, highly available, reliable, and scalable. When creating a storage account, you first need to choose an account type. The account type influences the storage services and redundancy options, affecting the way you can use it. But what do I mean by redundancy options, you might ask? In Azure Storage, multiple copies of data are always stored to protect against planned or unplanned events such as hardware, network, or power failures, natural disaster, and more. Redundancy ensures that your storage account meets the target availability and durability even in the event of failures. When deciding on the best redundancy option for your scenario, aim to find the optimal balance between cost and high availability. Locally redundant storage (LRS) replicates data 3 times within a single data center in the primary region. LRS ensures object durability of at least 99.99999%. That is 11 nines over a given year. LRS is the most cost-effective option and provides the lowest redundancy level comparing to other replication choices. While LRS protects your data against server and disk rack failures, in the event of data center disaster, such as a fire or a flood, all replicas of the storage account using LRS might be lost or not recoverable. Zone redundant storage (ZRS) ensure object durability of data in Azure Storage Services of at least 99.999999999 12 nines over a given year. For applications that requires a high level of reliability, you can also copy data from your storage account to an additional region located hundreds of kilometers away from the primary region. If you copy your storage account data to an additional region, it remains resilient even to catastrophic failures that could make data recovery in the primary region impossible. When creating a storage account, you choose the primary region for the account. The additional paired region is based on Azure region pairs and cannot be changed. Azure Storage offers 2 options for copying data to an additional region: Geo-redundant storage, GRS, and Geo-zone redundant storage, GZRS. GRS is similar to having LRS in 2 regions, while GZRS combined having ZRS in the primary region and LRS in the additional region. GRS performs synchronous data copies 3 times within a single physical location in the primary region using LRS. Data is then asynchronously copied to a single physical location in the additional region pair using LRS. GRS ensures object reliability of data in Azure Storage Services of at least 99.99999%, that is 69 over a given year. Geo-zone redundant storage, GZRS, combine high availability from zone redundancy with protection against regional failures via geo-replication. Data in the GRS storage account is copied to 3 Azure availability zones in the primary region, as well as replicated to an additional geographical region using LRS for protection against regional disasters. Microsoft recommends using GZRS for applications that require the highest consistency, resiliency, and availability, along with excellent performance and disaster recovery capabilities. Now let's visually compare our redundancy option. For regions supporting availability zone, locally redundant storage performs synchronous data replication across 3 Azure availability zones within the primary region. Zone redundant storage replicates data within a single region across different data centers. Geo-redundant storage replicates data 3 times within a single physical location in the primary region using LRS. Then, the data is asynchronously copied to an additional physical location in a secondary region. GeoZone redundant storage copies data to 3 Azure availability zones in the primary region, similar to ZRS, and replicates it to an additional geographical region using LRS. Now that we have covered data redundancy, let's move on to data services. The Azure Storage Service Platform includes the following data services: Azure Blob, Azure Disk, Azure Queue, Azure Files, and Azure Tables. Azure Blob Storage is a solution for storing objects in the cloud. It can store large volume of data, such as text or binary data. Azure Blob Storage is unstructured, meaning it can contain various types of data. It can handle thousands of parallel uploads, large video or image data, constantly growing log files, and is universally accessible with an internet connection. The second type of data service is Azure Disk Storage or Managed Disks, which are block-level storage volumes managed by Azure for use with Azure virtual machines. Essentially, they function like physical disks, but virtualized for added resilience and availability compared to physical disks. With Managed Disk, you only need to prepare the disk and Azure takes care of everything else. The third type of storage is Azure Queue Storage. It's a service for storing large numbers of messages. You access messages from anywhere in the world via authenticated calls using HTTP or HTTPS. A queue may contain millions of messages, up to the total capacity limit of a storage account. Queues are commonly used to create a backlog of work to process asynchronously. The fourth type of data service is Azure Files, which provides fully managed shared file resources in the cloud accessible via standard industry, SMB, or NFS protocols. Azure Files can be simultaneously connected to cloud and on-premises deployments. SME shares of Azure Files are available for Windows, Linux, and Mac OS clients, while NFS shares are available for Linux or Mac OS clients. And finally, Azure Table Storage is a service that stores non-relational structured data, also known as structured NoSQL data, in the cloud, providing a key attribute store with a schema-less design. You can use table storage to store flexible data sets like user data for web applications, address, books, device information, or other types of metadata your service requires. You can store any number of entities in a table, and the storage account may contain any number of tables, up to the capacity limit of the storage account. On this table, you see the public endpoints of storage services: Blob Storage, Data Lake Storage Generation 2, Azure Files, Queue Storage, and Table Storage. Your storage account's flexibility doesn't stop there. It's also equipped with different access tiers, tailored to accommodate a variety of data storage scenarios. The Azure Storage Service offers different access tiers for storing blobs, providing the most cost-effective data storage options. The possible access tiers are hot, cool, cold, and archive. The hot storage tier is optimized for frequently accessed data, such as images for a website. The cold storage tier is optimized for infrequently accessed data stored for at least 30 days, such as customer invoices. The cold tier is an online storage option optimized for data that is infrequently accessed or modified. Data in the cold tier should be stored for a minimum of 90 days. The cold tier has lower storage cost and higher access cost comparing to the cool tier. The archive storage tier is intended for rare access data stored for at least 180 days, with relaxed retrieval time requirements, such as long-term backups. When your data is stored in an online access tier, whether hot, cool, or cold, users can access it immediately. The hot tier is the best choice for data that is in active use. The cool or cold tiers are ideal for data that is accessed less frequently but still needs to be available for reading and writing. While cool data comes with a slightly lower SLA for availability and higher access costs comparing to hot data. It's a reasonable compromise considering the lower storage costs. In archive storage, data is offline, which provides the lowest storage cost but comes with higher cost for data retrieval and access. As mentioned before, data must remain in the archive tier for at least 180 days, and early removal will incur charges. While a blob is in the archive tier, it can't be read or modified. To read or download a blob in the archive tier, you must first rehydrate it to an online tier, either hot, cool, or cold. Data in the archive tier can take up to 15 hours to rehydrate, depending on the priority you specify for the rehydration operation. Now, let's finally take a look at our storage services directly on the portal. In this demo, we will see how to create a blob and a storage account. If we want to upload a blob, we will need to have a storage account, so it will be our first step. Right, we will need to find a service that is called storage account. Use the plus button to create a resource as we did in previous demos. We'll select create. And we'll need to provide the information about subscription and resource groups. We can use the resource groups that we created during our VM creation. And after that, we will need to provide a storage account name that is global and unique. Also, it will be informed in this info box. So the name must be unique across all existing storage account names in Azure. It's very important, otherwise you can't create a storage account. So I will create one. No contoso with Alexandra. Long name to be sure that it's a unique one. And it works now, you see. I can continue. I will keep the same region that is close to me. And I can also select performance. Is it standard or it's a premium one that I would like to have? If I need a low latency, I will go with standard. And I will need to select redundancy option. I have all redundancy options that we discussed: LRS, GZRS, ZRS, and GZRS. I will select LRS, it is less expensive one, and I'm using the storage account just for a demo. I have also different advanced options for security that you don't need to know to pass AZ-900 exam, but you need to know that you have extra feature if you want to enhance your security. After that, we have networking. I will keep by default that I want to have a public access from all networks, but if I want to have access just from selected specific virtual network, I can select it here, or if I want that just some IP addresses can access my storage account, I can also modify it on this page. We have a data protection option that is very interesting because we have a soft delete. Soft delete means if I delete some element or some blob, it will be kept for 7 days in my trash bin. So by default, it's 7 days, and it helps to protect the data from accidental deletion, for example. And if you want, you can modify the number of days on this page. We have also encryption. If I want to go, for example, for custom manager keys for encryption, no worries, again, it's a bit out of scope of AZ-900, but you have those advanced options here. We have tags as we had them on previous resource creation, and in the end we have review, and we can create our storage account. Let's hit create, starting the deployment, and usually it will take 1-2 minutes to create your storage account, and after that we can go inside and create our container to add a blob inside. So deployment is in progress. Let's wait a bit. Wonderful, our resource is created. Let's go to our storage account. So here we have an overview, and as well we have data storage with 4 different options that we saw on our deck: containers, file shares, queues, and tables. For blob creation, we will need to use containers, so we'll select in data storage containers and add a new container via our plus button. Let's select a container and provide a name to it, AZ-900. And we have different public access level: private, no anonymous access, blob, anonymous read access for blobs, or containers where we give anonymous access for read to our containers and to our blobs. I will use a private one, and if I want, I can also set up encryptions, extra capabilities in advance, but for the simple demo, I will just select a private public access and create my container. After, I can go inside of my container and upload a blob inside. I will browse for files. Here I have one blob that I prepared, and I will click upload. So we have successfully uploaded our blob, and now let's say we want to share it. I have an URL link here to my blob, but if I would like to share with some external users, as it's in private access, I will need to generate a key. You see, I have here a SaaS. So if I would like now to share it with someone out of my organization to see this image, I will use generate SaaS, and I can provide just in time access to my blob in private access. So it's very important to select the permissions. I will give just read access to this blob and select when I'm giving access, and I can generate a SaaS token to have temporary access to this image outside of my organization. And to test it, let's open new in private tab and try to access our image. And here we have a beautiful statement: keep calm and configure Azure. It's what we're learning together today. So thank you for your attention to this demo. We saw together that we need first to create a storage account. After that, we will create a container and upload blob inside, and we can share it thanks to SaaS for a specific amount of time. Thank you for your attention. Let's come back to our presentation. Transitioning from the exploration of storage access tiers, let's shift our focus to another pivotal facet: migration to Azure. This seamless transition is empowered by the robust Azure Migration Service, offering an unified solution for migrating, modernizing, and optimizing resources. All pre-migration stages, such as discovery, assessment, and right-sizing of on-premises resources, are incorporated into the infrastructure, data, and applications. The scalable platform of the Azure Migration Service allows for the integration of third-party tools, expanding the range of supported use cases. The Azure Migration Service acts as a centralized management hub for assessing and migrating on-premises data centers to Azure. It offers a single portal to initiate, execute, and track the progress of migration to Azure. The Azure Migration Service integrates with other Azure services and tools, as well as offering from independent software vendors. Through the Azure Migration Center, you can assess and move your on-premises infrastructure to Azure. Azure Data Box is a physical migration service that enables fast and reliable transfer of large volume of data with minimal costs. The secure data transfer is facilitated by delivering the data box storage device with a maximum capacity of 80 terabytes. Data box is transported to and from the data center through a regional transportation service, and its reinforced casing protects it from damage during transportation. You can order the data box on the Azure portal to import and export data to and from Azure. Once the device arrives at your data center, you can quickly set it up using a local user interface. After completing the data transfer to or from Azure, simply return the data box. When transferring data to Azure, the data is automatically sent back to Microsoft after they receive the data box. The entire process is managed through the data box service on Azure portal. Databox is ideal for transferring data exceeding 40 terabytes when network connectivity is limited or unavailable. Data movement can be a one-time, periodic, or initial bulk data transfer operation followed by periodic transfer. In addition to large-scale migration using services like Azure Migration and Azure Data Box, Azure also provides tools for moving individual files or small files groups and interacting with them. These tools include AZ Copy, Azure Storage Explorer, and Azure File Sync. AZ Copy is a command line utility that can be used to copy blobs or files to or from a storage account. With AZ Copy, you can upload, download, copy files between storage accounts, and even synchronize files. AZ Copy can also be configured to work with other cloud service providers to move files between clouds. The second service in the center of my screen is Azure Storage Explorer, which is a standalone application that provides a graphical interface for managing files and large binary objects in your Azure Storage account. It works on Windows, macOS, and Linux and uses AZ Copy on the server side to perform all files and blob management tasks. With Azure Storage Explorer, you can upload data to Azure, download the data from Azure, and move data between storage accounts. And the third service in the right side of my screen is Azure File Sync. It's a tool that centralizes shared folders in Azure files while maintaining the flexibility, performance, and compatibility of a Windows file server. It's almost like transforming your Windows file server into a miniature content delivery network. Once you install Azure File Sync on your on-premises Windows server, the service will automatically keep your files in sync with your Azure files. With Azure File Sync, you can maintain any number of caches you need in any region of the world and replace a failed on-premises server by setting up Azure File Sync on a new server in the same data center. Additionally, Azure File Sync allows you to set up cloud tiering, where the most frequently accessed files are kept locally, while less accessed files are stored in the cloud until requested.
That concludes our fourth session. Let's recap what we have learned in it. Firstly, we learned about storage account. and how to compare Azure storage services such as containers, files, and disks, as well as how to describe storage tiers and redundancy options. We explored locally redundant storage (LRS), G-redundant storage (GRS), zone redundant storage (ZRS), and GIA zone redundant storage (GZRS). After the session, we can identify migration options, including Azure Migration and Azure Data Box. And at the end of the session, we learned how to describe file movement options, including AZ Copy, Azure Storage Explorer, and Azure File Sync. Thank you for your attention. Welcome to our fifth session. In this session, we will discuss security, access control, and cost management in Azure. Specifically, in the first lesson, we will cover Microsoft Entra ID, authentication methods, and security models. In the second lesson, focused on cost management, we will explore cost calculators and pricing, and conclude the session with cost management and tags.
Let's begin with authentication and security methods, my favorite topic. Security has become a very relevant subject in recent years. And during the COVID-19 period, the number of cyber attacks in some countries has more than doubled. We'll start our learning in this session with Microsoft Entra ID. Microsoft Entra ID, previously known as Azure Active Directory, is a cloud service for managing identities and access. This service helps your employees access external resources, such as Microsoft 365, Azure Portal, and thousands of other SaaS applications. Microsoft Entra ID also grants access to internal resources, like applications on your corporate intranet, as well as any cloud applications developed for your organization. Microsoft Entra ID is a cloud-based identity and access management service from Microsoft. With Microsoft Entra ID, you manage the identity credentials, but Microsoft ensures the global availability of this service. If you have worked with Active Directory, currently known as Microsoft Entra Domain Services, Microsoft Entra ID will be familiar to you. When you connect to Microsoft Entra ID, Microsoft protects you by detecting suspicious login attempts at no additional cost. For example, Microsoft Entra ID can detect login attempts from unexpected location or unknown devices. After selecting a Microsoft Entra ID license, you will gain access to all or some of the features for your organization, which you can see on the slide: authentication, self-service password reset, multi-factor authentication, business-to-business B2B, application, and device management. We will discuss these features in more details in this session. Similar to how Microsoft Entra ID lets you use directory services without needing extra setup, Microsoft Entra Domain Services offers domain benefits in the cloud without the complexity of setting up and managing domain controllers. Known as Microsoft Entra DS, it handles tasks like joining domains and applying group rules. This is useful for running older cloud apps that can't use modern logins or to avoid changing settings often. You can move these older apps to the managed domains, avoiding the need for complex management. It works with your Microsoft Entra ID, allowing users to use their credentials for logging in, and you can still use existing accounts and groups for security when accessing resources. This helps make moving from on-premises to Azure smoother. Next, we'll talk about Microsoft Entra ID's features, starting with authentication. Authentication is like presenting identification during travel, for example, at the airport check-in counter. It doesn't confirm the presence of a travel document. It simply confirms that you are who you claim to be. Azure supports several authentication methods, including standard password, single sign-on, SSO, multi-factor authentication, MFA, and passwordless authentication. While authorization influences the level of access granted to the authenticated entity, it also defines what data they can access and what actions they can perform. In our airport example, it will be like checking your boarding pass to determine where exactly you can sit on the plane. Another important feature of Microsoft Entra ID is multi-factor authentication. Remember how you log into websites, emails, or online services. Have you ever entered a code sent to your phone after entering your username and password? If so, you have used multi-factor authentication, MFA, for login. MFA is the process of requesting additional data or an additional authentication factor or verification from the user during login. MFA helps protect against password compromise. MFA provides extra credential security by requiring 2 or more elements for authentication. These elements fall into the following categories. Something you know, this could be a complex question. Something you have, this could be a code sent to your mobile phone, or something you are. Usually some biometric characteristic, such as a fingerprint or a facial image. Let's move now to the external identities. Surely, you have worked with various companies that required access to your resources. To secure this access, we have external identities. An external identity refers to users, devices, services, etc. that are outside of your organization. Microsoft Entra ID external identities encompass all the ways you can securely interact with users outside your organization. If you want to collaborate with partners, distributors, suppliers, or vendors, you can grant them access to your resources and determine how your internal users can access external organizations. If you're a developer creating consumer-facing applications, you can manage your customers' use of credentials. External identities can look similar to single sign-on. With external identities, external users can use their own credentials. If they have a digital identity issued by a corporation or government entity, or unmanaged social identities such as Google or Facebook, they are able to use their own credential for signing in. Using the Microsoft Entra ID B2B or business-to-business feature, you can easily enable collaboration within your organization. Administrators or other users can invite guest users from other customers. This feature also applies to social identities, such as Microsoft accounts. As we have a B2B offer, Microsoft also provides a B2C. External Identities B2C provides a service for corporate identity management for customers. Your customers will have the ability to log in to your applications and APIs using selected social, enterprise, or local account credentials. Microsoft Entra ID B2C is a customer identity and access management solution capable of serving millions of users and handling billions of authentication checks daily. The solution takes care of scaling and securing the authentication platform, monitoring, and automatically responding to various threats such as the denial of service attacks and password spraying. B2C is a separate service in Microsoft Entra ID. It is based on the same technology as Microsoft Entra ID but serves a different purpose, allowing you to build applications for customers and then let all users register for these applications without restrictions on user accounts. Another important feature of Microsoft Entra ID is a conditional access. Conditional access also provides more granular multi-factor authentication for users. For example, users may not need to provide a second factor authentication if they are in a known location. However, if login signals are unusual or the user is in an unknown location, they may be prompted for a second factor. When signing in, conditional access collects signals from the user, makes decisions based on those signals, and then applies the decision to allow or block access or require multi-factor authentication. Managing access to cloud resources is a crucial function for any organization using the cloud. Role-based access control in Azure, Azure RBAC, allows you to manage user access to Azure resources, including configuring permissions for performing operations on those resources and defining access scopes. In a multi-team cloud environment, the principle of least privilege ensures access is granted only at the necessary level. For instance, if you require read-only access to a specific blob in storage, then only read access should be provided for that particular object. Write access should not be granted for that object, and read access should also not extend to other blobs in storage. This guideline offers a significant security recommendation. Azure RBAC includes over 70 built-in roles, can be assigned in different scopes, and allows you to create your own customer roles. Each role has a set of access permissions associated with it. There are 4 fundamental Azure roles: owner, contributor, reader, and user access administrator. The owner role wields complete control over resources. Owners can manage access, modify resources, and even delegate access to others. The contributor role maintains the ability to create and manage resources, excluding access management. The reader role possesses the privilege to view existing resources but not modify or create new ones. The user access administrator role specializes in managing user access to Azure resources, making it an indispensable role for access management tasks. With understanding of these fundamental roles, you will navigate the Azure RBAC landscape with clarity and ensure precise access controls for your resources. When it's come to safeguarding your data across various levels, the concept of defense in depth takes center stage. The principle behind defense in depth is to implement a variety of measures that collectively restrain the progress of unauthorized access attempts to your data. Just as Microsoft is committed to securing data, your dedication aligns with ensuring its protection as well. let's turn our attention to the chart displayed, which illustrates the layers of protection. Each layer contributes to defense. Even if one layer is compromised, the subsequent layer acts as an additional barrier against further breach. Turning our focus to the individual layers, we start with the physical security level. This level is all about ensuring secure access to buildings. At Microsoft data centers, multiple security checkpoints and identity verifications are required for entry. This level is exclusively dedicated to physical security measures. Transitioning to the identity level, the focus shifts to controlling access to the infrastructure. This level ensures that access is granted only to those who truly need it. Moving on to the perimeter level, the primary objective is to prevent unauthorized users or services from gaining access to the network. This layer serves as a frontline defense against threats like distributed denial of service (DDoS) attacks. At this level, alerts are triggered, enabling the monitoring of potential attacks. Moving to the network level, the primary concern is the isolation of resource access. This ensures that if an attack occurs, its spread to other services is contained. At the compute level, protective measures involve securing your environment by closing specific ports. Comprehensive protection and necessary control are pivotal at this stage. The application-level security requires integrating security into development projects, ensuring that applications are inherently secure by design. Finally, we arrive at the data layer. Despite the contribution of the other layers, responsible data access holds immense significance. This final layer ensures that those with authorized access adhere to data protection standards. Data layer security includes controls to manage access to businesses and customers' data and encryption to protect data. The Microsoft approach to defense in depth, demonstrated through this multi-layered strategy, fortifies its assets. By embracing this approach, you too can effectively secure your resources and data. This layered methodology effectively combats a wide range of potential threats and should be a cornerstone of your security strategy as well. Zero Trust is a security model that assumes the worst-case scenarios and protects resources accordingly. The Zero Trust model starts with the assumption of a breach, and every request is checked as if it were coming from an untrusted network. Today, organization needs a new security model that effectively adapts to the complexities of the modern environment, supports workforce mobility, and protects people, devices, applications, and data wherever they are. To address the challenges of the new world of computing, Microsoft strongly recommends using the Zero Trust security model, which is based on the three guiding principles. First, verify explicitly. Always authenticate and authorize based on all available data points. Secondly, use least privilege access. Limit user access with the just-in-time and just enough access, risk-based adaptive policies, and data protection to protect both data and productivity. And finally, assume breach. Segment access by network, user, devices, and application. Use encryption to protect data. And use analytics to get visibility, detect threats, and improve your security. Furthermore, we possess a strong tool aligned with this model, known as Microsoft Defender for Cloud. Microsoft Defender for Cloud is a monitoring tool that manages security posture and provides threat protections. It monitors cloud, on-premises, hybrid, and multi-cloud environments and offers recommendations and alerts to strengthen your security. Defender for Cloud provides the necessary tools to protect resources, control security state, defend against cyber threats, and optimize security management. Deploying Defender for Cloud is straightforward as it natively integrates into Azure. Defender for Cloud continually tracks new resources deployed for your workloads. It assesses whether new resources are configured in accordance with security best practices. If not, they're flagged, and you receive a prioritized list of recommendations on what needs to be fixed. These recommendations help reduce the likelihood of attacks on each of your resources. The list of recommendations is aligned with and maintained by the Azure Security Benchmark. The Security Benchmark provides guidelines with security and compliance recommendations for Azure, prepared by Microsoft based on widely accepted compliance frameworks. In this way, Defender for Cloud not only enables you to configure security policies, but also applies security configuration standards to your resources. Now, let's move on to a very important topic: how to manage your finances and maximize saving with Azure. The cost of Azure resources is influenced by several factors. Let's discuss 6 important factors. The first factor is the type of resources. When you provision an Azure resource, Azure creates metered instances for that resource. The meters track the resources usage and generate a usage record that is used to calculate your bill. The second factor is consumption. As we mentioned in our first session, the pay-as-you-go model is the cloud payment approach where you are billed for the resources utilized during the billing cycle. If you consume more compute resources in this cycle, your payment will be higher. If your usage is lower in the current cycle, your payment will be reduced. It's a straightforward pricing mechanism that offers maximum flexibility, as we previously discussed. As mentioned earlier, you're only charged for what you actually use. This direct pricing mechanism provides maximum flexibility. However, Azure also allows you to continuously use a specific fixed amount of cloud resources and receive discounts on these reserved resources. Many services, including databases, compute resources, and storage, offer the ability to set a fixed level of usage and receive discounts. In some cases, discounts can reach up to 72%. When you reserve capacity, you define a fixed amount of Azure resources usage and payment for a specific period. Usually it's 1 or 3 years. Using reserved capacity allows significant saving when using stable or predictable workloads, while still having the flexibility to increase cloud resources as needed. The third factor is maintenance. The flexible capabilities of the cloud allow you to quickly adjust resources on demand. Monitoring in Azure helps you preserve financial resources by providing various recommendations, such as shutting down underutilized virtual machines. By tracking resources and not retaining resources that are no longer needed, you can effectively control cloud costs. The first factor that affects cost is the geography and placement of your resources. When provisioning most resources in Azure, you need to specify the region where the resources will be deployed. Azure infrastructure is distributed globally, allowing you to deploy services centrally or as close as possible to where your customers use them. Such global deployment results in global price differences. The cost of electricity, labor, taxes, and fees varies depending on the location. Due to such cost variation, the deployment cost of Azure resources may differ depending on the region. Network traffic, our fifth factor, also depends on geographical location. For example, data movement within Europe incurs lower cost than data movement from Europe to Asia or South America. Billing zones are a factor that determines the cost of some Azure services. Bandwidth refers to data movement to and from Azure data centers. The fifth factor is network traffic. In some cases, inbound data transfer is provided at no cost. Charges for outbound data transfer depends on billing zones. And finally, the sixth factor is subscription. Some types of Azure subscription also include usage quotas that affect costs. For example, the free Azure trial subscription provides access to a range of Azure products for free for 12 months. It also includes credit for expenses during the first 30 days from the registration date. You get access to over 25 products that are always provided for free. Now that we have examined the dynamics of resource placement and network traffic cost, let's shift our focus to the Azure Marketplace platform that extends your Azure experience by offering solutions and services from third-party providers. This can include servers with pre-installed and configured software, devices with managed network firewalls, or connectors for third-party backup services. When you purchase products through the Azure Marketplace, you may pay not only for Azure services you use, but also for the third-party provider services. In this case, the billing structure are determined by the provider. All solutions available in the Azure Marketplace are certified and comply with Azure policies and standards. Certification policies may vary depending on the type of service or solution, as well as the Azure service. Emerging from the Azure Marketplace insights, let's now turn our focus to the pricing calculator, an available tool in comprehending potential Azure expenditures. This calculator is freely available online and allows you to estimate the approximate hourly and monthly cost of using Azure. The pricing calculator is designed to provide an estimated cost of provisioning resources in Azure. You can pre-assess the cost of individual resources, build a solution, or use a sample scenario to view Azure cost estimates. The main focus of the pricing calculator is on the cost of provisioned resources in Azure. With the pricing calculator, you can evaluate the cost of all provisioned resources, including compute resources, storage, and associated networking expenses. You can even consider various storage options, such as storage type, access tier, and redundancy. To better understand how the pricing calculator works, let's take a look at it in the browser. In this demo, we'll review together Azure pricing calculator that helps us estimate our hourly or monthly cost for using Azure. It's a public website that you can also access via the provided URL, or you can just Bing it and find it on internet. If I want to save my cost estimates, I will need to log in inside. I will not log in, I will just show you how we can review cost inside. But for your information, if you need to save your progress, please log in while you're using it. Let's add some virtual machine. Let's add some storage account. It's very simple. You just need to select the elements. You have different filters on the left, or you can just select the most used services here. And after that, to review. So we have now one VM, we have one storage account, and after that we can decide where the storage account is based. So if we will change the region, the price will be modified. So now we have $2 here. Let's say we are moving to UK South from East US, and directly we have different price that it's visible. Also, if we move to our example with North Europe that I used before, and we look on the price is again different from the previous one. So what we can do as well, we can select the type, we can select the performance. The performance will also impact the price. You see also it's much higher, let's say, price. The difference is very, very visible. And we can also select the storage account type and review how it changes the price, access tiers. Here we have archives, but if we move to hot, we'll have different pricing. For sure, when we're moving to archives, the price is very low, but we'll pay a lot for registration if we'll need one. But if you come to hot, also the price will increase. So it's a very flexible tool. You see, I can modify every setting for my storage and see how the price is different. I was in LRS, GZRS also impact my price. But it's very interesting here. Let's say we'll put a bit more storage. And now I am on $126. I have an option that it's called saving options, where I can decide if I want to use reserved instances. So I can reserve this resource for 1 or 3 years. And let's see what's happened. I have $126. If I reserve my storage account for 1 year, and I want to decide if I then paid it on front, it will impact, and we will see the average price per month directly. It's absolutely different. The same, I can decide if I reserve it for 3 years. So we see that the amount decreased again. The same with the operational data transfer. According to the number of operation, we have different pricing. And also, sometimes the pricing for specific characteristic will be not available for the region. So if I want, I can switch to another region. It's absolutely normal. Some regions, they have more opportunities and more information. Some have less. But please be aware that here you can review your upfront cost and your monthly cost if you will reserve some instances. So if I go with pay as I go, I can review again, the price will be different. I have now 0 upfront costs. And after that we have our VMs. If I select, for example, our North Europe, I will select Windows. I can also modify our tiers. I will go for standard. Basic will be always less expensive one. I have $13. If I go for standard, I have $14. So the price is again changed. And after that, if I would like to, I can decide something related to my memory. Like I want 56 GB of RAM. Again, the price is higher. And as well, if I want to go to Linux, for sure the price will be less expensive, as we can see here. And again, you can use reserved instances for 1 year, as you can use reserved instances for 3 years, and you can select the plan that you would like to use. Pay attention that some option is not available for specific instance. So if I want, for example, to come back to Windows, I can also decide if I want, for example, to use already the license included or no, and everything will modify my price. And I have also the information about the disk, so more space I take, more I pay. It's visible quite here. And as well, we can scroll the full page by selecting the characteristics. And after that, at the end, we can decide if we want to save it. If you're logging in the platform, we can save it, or we can export it in Excel. And now let's see if I make my export and I open my file. We can review everything that we selected here with the pricing and use this document for our financial department and for our budgeting. So I hope you enjoyed this demonstration, and now you know how the cost is impacted in Azure. Thank you for your attention, and let's come back to our presentation. Having explored the pricing calculator, let's now transition our focus to the total cost of ownership TCO calculator. It's an essential tool for comparing the financial landscape of on-premises infrastructure against Azure cloud infrastructure. Using the TCO calculator, you input your current infrastructure configuration, including servers, databases, storage, and outbound network traffic. The TCO calculator then compares the expected cost for your current environment with the Azure environment that meets the same infrastructure requirements. In the TCO calculator, you input your configuration and assumptions such as electricity cost and IT labor expenses, and you will receive an estimate of the cost differences for running the same environment in your current data center or in Azure. Let's now return to the browser and explore the total cost of ownership calculator. Welcome to our demo. We'll see together how to use total cost of ownership calculator. Here we can estimate the cost of our savings. It's also accessible in the public access on the internet, so you can also use it to estimate your cost. It's a free tool. Inside, first of all, we'll need to define our workload, so our current on-premises workload. Please try to be as most precise as possible. Why? Because more details you provide, more clear comparison you will have. So you will need to provide some information about servers. You can also name your workloads. You can add the second one. You can specify how many gigabytes you're using. You can add different databases, name it correctly. Also provide the space, the different information about their location, operations that you're doing inside, destinations, and etc. Also, after you provided all information about your databases, you will need to provide the info about your storage account. So what is the capacity that you need, what are different types of disks that you're using currently, as well as networking. And after you provided all this information, for example, our destination region, let's say Canada, we will need to adjust our assumptions. When I'm saying adjusted our assumptions, so first of all, select the currency. You can keep it in dollars or you can switch in euro. That it's my current case because I'm based in France. We can also decide if we need also software insurance coverage provides Azure hybrid benefits. Also, if you'd like to have sheer redundant storage, we can activate it here, and etc. So we provide some extra assumptions about hardware cost, software cost, electricity, and etc. Again, more precise you are, more clear information you will get here. As soon as we provide all the assumptions and we define clearly our existing on-premises workflow, we can see the report. And so here in magic, if I use Azure, I can save 1,837,000 euros. It's quite a lot actually. It looks like I need to provide the consultant services to help people move to cloud now because it saves so much money. As well as I can decide if it's for 1 year, how much it will be saving, what is the region. So let's look if it's different for our North Europe that we use, for example. It's actually the same number. Also, we can decide if we have some different licensing programs, and also we have a specific dev test pricing if we like to include it inside. And also we have different graphs to see how the price change comparing to our on-premises actual cost and what the cost will be in Azure. So green line is Azure. And here we have the details by segment, so how much we spend on compute today, how much we spend on data center, and what we'll spend for the same services in Azure according to the information that we provided. So we have huge differences. So I see that now I spend more than 1 million and I can spend just 300,000 inside of Azure. So we have also detailed breakdown here. The information is very different, and it's why I mentioned before, it's very important that you provide as much detail as possible, because more details you provide, more realistic the data will be, because it's just an estimate related to the data that we provided in 2 previous pages. And at the end, as we have the differences of cost of on-premises comparing to Azure, we can download this report, share it with the colleagues, or save it. But for saving, we need to log in. So if I downloaded it, I will have a report provided in a PDF format with the graphs that we just saw together, and I can share it with my financial department, for example, to estimate the cost of migration. Very useful tool. I hope you enjoy it. Let's come back to our presentation. The cost management service allows you to easily track the expenses of your Azure resources. You can set up alerts for cost and create budgets to manage your resources more efficiently. You can find it within the billing and resource management sections, or as a standalone tool designed for teams managing costs across different scopes. You can also automate tasks and add cost-related features to your tools and processes. This enhances visibility and accountability for your organization's goals. Cost management works in the Azure portal, Microsoft 365 Admin Center, or Power BI. It also sends various emails and alerts to help you stay informed and manage your account and cost effectively. With the Azure Cost Management Service, there is an additional feature called Cost Analysis. This gives you a visual overview of your Azure costs. You can see your total cost in different ways, such as the billing cycles, regions, and resources. Cost analysis is helpful for studying and analyzing your organization's expenses. By looking at accumulated cost over time, you can identify trends and drivers, helping you understand your budget's impact. The more you use the cloud, the more important it becomes to maintain proper oversight. An effective organization strategy helps you comprehend your cloud usage and manage costs. One approach to arranging related resources is by placing them in separate subscriptions. Resource groups are also useful for managing interconnected resources. Resource tags offer yet another way to organize resources. These tags supply additional information or metadata about resources. It's important to note that tags are not inherited. This means you can apply tags at one level without them automatically displaying at another level. This flexibility allows for customizable tag schemes that can adapt based on the level, resource, resource group, subscription, etc. A resource tag consists of a name and a value, and each Azure resource can be assigned one or more tags.
With that, we conclude our 5th session. where we covered Microsoft Entra ID, authentication methods, security models, pricing and cost calculators, and cost management. Welcome to our final session. In this final session, we'll explore some features and tools that can be used to manage Azure environment. We'll also discuss the resources available for ensuring compliance with corporate or regulatory requirements. We'll cover 3 different lessons. First, we will focus on governance and compliance in Azure. Next, we'll discuss various deployment tools for Azure management. And in this third lesson, we'll explore different monitoring solutions.
Let's begin with Microsoft Purview. Microsoft Purview is a family of data governance, risk, and compliance solutions that can help your organization govern, protect, and manage your entire data estate. It combines the former Azure Purview and Microsoft 365 compliance solution and services together into a single brand. The Microsoft Purview helps you gain visibility into assets across your entire data estate and enables easy access to all your data, security, and risk solutions. Moreover, Microsoft Purview manages sensitive data across clouds, apps, and endpoints. It empowers your organization to govern, protect, and manage data in new comprehensive ways. Microsoft Purview includes unified data governance solutions that help you manage data services across your on-premises, multi-cloud, and software as a service estate. That includes Azure Storage Services, Power BI, databases like SQL or Hive, file services like Amazon S3, and many more. Access policies in Microsoft Purview enable you to manage access to different data systems across your entire data estate. Moving on to another vital component, we have Azure Policy. This service in Azure allows you to create and assign policies for resources control and auditing, as well as management. These policies ensure compliance with various resource configuration rules, ensuring adherence to corporate standards. Azure Policy enables you to define individual policies or sets of related policies called initiatives. Azure Policy assesses resources and identifies those that do not comply with the defined policies. It can also prevent the creation of non-compliant resources. Azure policies can be set at each level, allowing you to tailor policies to specific resources, resource groups, subscriptions, etc. Additionally, Azure policies can be inherited. So when you set a policy at a higher level, it automatically applies to all child groups. For example, if you set an Azure policy at the resource group level, all resources created in that resource group will automatically receive the same policy. Now, let's delve into the concept of resource logs. These logs play a crucial role in preventing accidental deletion or modification of resources. Just as you might have accidentally deleted a document and regretted it, resource logs help you avoid such incidents. Even with role-based access control, Azure RBAC, policies in place, there is a risk that users with the appropriate access level may occasionally delete critical cloud resources. Resource log prevents deletion or update of resources depending on the type of log. Resource logs can be applied to individual resources, resource groups, or even entire subscriptions. They can also be inherited. Meaning you place a resource log on a resource group, it applies to all resources in that group. There are two types of resource locks. One prevents user from deleting, while the other restricts users from modifying or deleting a resource. So delete lock means that authorized user can read and modify the resource, but they cannot delete it. Read-only means that authorized user can read the resource but cannot delete or update it. To better understand resource locks, let's take a look at how they can be configured in the portal. Welcome back to the portal. In this demo, we'll see how we can create locks. Locks can be created to different resources, virtual machines or storage accounts, for example. And we can use it to show you how. For it, I will select the storage accounts that we created together, demo controls with Alexandra, and I will scroll my left side menu to see different settings inside. And on my side of my settings menu, I have locks. So I will select locks and I will add a lock that I will call don't modify. I have two different types of lock, read-only. It means that I can just view the information inside of my storage account and I can't modify my storage account. And we have delete lock, that it means that I can modify the information inside of my storage account, but I can't delete it. We select read-only lock and we create it. Let's try to delete our storage account or modify it. If we'll try to modify or delete, we will have a message saying that we can't delete because we have a lock. Let's try. Confirm delete. And here we have failed to delete storage account because we have a lock. Please remove the lock and try again. So we can't delete because of our lock. And again, if we come back and we delete our lock and we will try to delete, let's refresh to see it. Now, if I delete it and I come back to review and I try to delete my resources by copying the name, delete, confirm delete, and here we have deleting storage account. So our lock was removed and I achieved to delete resources that I wanted. I hope you enjoyed this demo. Let's come back to our presentation. I hope you enjoyed the demo. Let's discover together the Microsoft Service Trust Portal. It provides various materials, tools, and other resources on how Microsoft Cloud Services protect your data, as well as how to manage cloud data security and compliance in your organization. The Service Trust Portal is a publicly accessible website by Microsoft Corporation to publish audit reports and other information related to compliance requirements concerning Microsoft Cloud services. The Service Trust Portal users can download audit reports created by external auditors and access analytical information from Microsoft technical documentation, which contains details on how Microsoft Cloud Services safeguard your data and manage cloud data security and compliance in your organization. To access some resources on the Service Trust Portal, authentication verified user need to sign in with their Microsoft Cloud Service account, review and accept the Microsoft Compliance Materials Non-Disclosure Agreement. Additionally, on this portal you can use My Library feature to add documents and resources, allowing you to access documents related to you in one place and receive notifications when they are updated. We are moving forward to the second lesson in this session. In this lesson, we'll get familiar with the features, tools for managing, and how to put Azure resources into action. We'll dig into what the Azure portal can do, explore Cloud Shell's capabilities, and understand how to use PowerShell and CLI. Additionally, we will learn about Azure Resource Manager and Cover Bicep, a useful tool for managing resources. You'll also discover Azure services that make handling both on-premises and multi-cloud setup easier. We will look at Azure Arc to manage Azure's power beyond its usual reach, giving you more control and flexibility. To make the most of Azure capabilities, you will need a reliable way to interact with Azure environments, management groups, subscriptions, resource groups, resources, etc. Azure provides a range of tools for environment management, including Azure Portal, Azure PowerShell, and Command Line Interface CLI. Now, let's explore how these tools integrate seamlessly within the Azure environment. The Azure Portal ensures resilience and constant availability with presence in each Azure data center. This configuration makes the Azure Portal resilient to individual data center failures and helps avoid network latency due to proximity to users. The Azure Portal is continuously updated and doesn't go offline for maintenance. Azure Cloud Shell is a browser-based shell tool that allows you to create, configure, and administer Azure resources using the shell. Azure Cloud Shell supports both Azure PowerShell and Azure CLI, which is a bash shell. Azure Cloud Shell doesn't require local installation or setup. It authenticates using Azure credentials, so it already knows who you are and what permissions you have upon login. Azure PowerShell is the shell that enables developers, DevOps specialists, and IT professionals to execute command called commandlets. These commands invoke the Azure REST API to perform management tasks in Azure. The Azure CLI has the same functionality as Azure PowerShell, but with commands written in bash. Azure CLI provides same benefits of handling discrete tasks or orchestrating complex operations with code. It can also be installed on Windows, Linux, and Mac platforms, as well as accessed via Azure Cloud Shell. Since Azure PowerShell and Azure CLI based on bash offer similar capabilities and access procedure, I advise using the one you're most familiar with. And don't worry, for passing the AZ-900 exam, you don't need to know how to write these commands. Transitioning from the essential tools using to interact with Azure environments, let's now delve into the underlying structure that ensures seamless integration and consistent management. Azure Resource Manager, ARM, is a deployment and management service for Azure. It provides a level of control to create, update, and delete resources in your Azure account. Every time you perform any action with Azure resources, ARM is used. When a user submits a request from any Azure tool or API, it is directed to ARM. ARM performs authentication and authorization checks on the request. It then forwards the request to the appropriate Azure service that takes the request action. It then forwards the request to the appropriate Azure service that takes the requested action. Since all requests are processed through a single API, results and capabilities remain consistent across different tools. The concept of infrastructure as a code in Azure transforms resources management by using code for provisioning and configuration. Infrastructure as a code, or IaaS, involves defining infrastructure through code scripts, replacing manual setups. This consistently minimizes errors and ensures reproducibility. IaaS fosters collaboration via version controls and shared scripts, promoting teamwork and consistent configurations. Scalability becomes effortless. Code-based replication avoids manual duplication complexities. Implementing IaaS means version controlling code, testing scripts, and using Azure's tools for verification. Infrastructure as a code empowers efficient Azure resource management through automation, consistency, and collaboration. Azure Resource Manager integrates seamlessly with IaaS through ARM templates, JSON files that define and deploy resource accordingly. So ARM templates are an example of infrastructure as a code in action. With Aure templates, you can describe the resources you want to use in a declarative JSON format. The Aure template deployment validates the deployment code before any execution, ensuring that resources are created and connected correctly. The template then manages the parallel creation of these resources. For instance, if you need 50 instances of the same resource, all 50 instances are created simultaneously. Developers, DevOps specialists, or IT professionals only need to define the desired state and configurations of each resource in Azure Resource Manager template. And the template takes care of the rest. Aure templates can even run PowerShell and CLI scripts before or after resource configuration. They enable the declarative creation and deployment of the entire Azure infrastructure, including virtual machines, networking infrastructure, storage systems, and other necessary resources. You can write Aure templates two different ways, by using JSON and by using Bicep. Bicep uses a declarative syntax that you treat like application code. Treating your infrastructure as a code enables you to track changes to your infrastructure requirements and makes your deployment more consistent and repeatable. Bicep is intended to be easy to understand and straightforward to learn, regardless of your experience with other programming languages. All resource types, API versions, and properties are valid in Bicep templates. If you have previously looked into using JSON templates, you will notice that Bicep simplifies the template creation experience. It provides a similar syntax for writing templates. You can reference parameters and variables directly without using complicated functions. You can reference the properties of a resource directly by using its symbolic name instead of complex reference statements. In most situations, Bicep automatically detects dependencies between your resources. This process removes some of the work involved in template authoring. You can see on this slide an example of how to deploy a storage account using Bicep. If we examine the JSON code, we will notice that the code required to deploy a storage account will be twice as long as the equivalent in Bicep. For comparison, let's take a look at this JSON code on the next two slides. As you can observe, it takes 2 slides to demonstrate the same task in JSON, which also appears more intricate compared to Bicep. Managing hybrid and multi-cloud environments can quickly become complex. Azure offers multiple tools for provisioning, configuring, and monitoring Azure resources. But what about on-premises resources in hybrid configurations or cloud resources in multi-cloud setups? Azure Arc. Azure Arc allows extending Azure governance and monitoring to hybrid and multi-cloud configurations. The Azure Arc service simplifies management and administration by providing a unified management platform for multiple clouds and on-premises environments. Azure Arc enables projecting existing non-Azure and/or on-premises resources into Azure Resource Manager. This means you can manage virtual machines, Kubernetes cluster, and databases as if they were running in Azure. You can utilize familiar Azure management services and capabilities regardless of where the resources are located. Additionally, Azure Arc offers a cohesive experience by allowing you to view your Azure Arc-enabled resources uniformly. Whether you prefer the Azure Portal, the Azure CLI, Azure PowerShell, or Azure REST API, Azure Arc provides a unified approach to managing your diverse resources. This simplification enhances your operational efficiency and control across complex environments. And finally, we move to our last lesson in this session, where we will discuss monitoring. Azure Advisor evaluates Azure resources and provides recommendations to enhance reliability, security, performance, efficiency, and cost savings. Azure Advisor was designed to save your time on cloud optimization. This recommendation services includes proposed actions that you can take immediately, defer, or dismiss. You can access recommendations through the Azure portal or via the API. Additionally, you can configure notifications to alert you about new recommendations becoming available. With a solid grasp of how Azure Advisor enhances resources management, let's pivot to another indispensable tool, Azure Service Health. Azure Service Health helps monitor your Azure resources, both individual deployed resources and overall Azure status. Azure Service Health achieves this through a combination of three different Azure services. First, Azure Status. Azure Status provides a broad view of Azure's global health status. It informs you about service outages in Azure through the Azure Status page. This page offers a global perspective on the operational status of all Azure services across all Azure regions, making it a valuable guide for incidents with wide-ranging consequences. Secondly, Service Health. Service Health offers a narrower view of services and Azure regions that you use. It's the best tool to find information about issues affecting the functionality of services, planned maintenance, and optimization recommendations for your solutions. You can even configure Service Health alerts to receive notification about service issues, planned maintenance, and other changes that may impact your used Azure services and regions. Thirdly, Resource Health is a specialized view of your actual Azure resources. The service provides information about the operational status of individual cloud resources, such as specific virtual machine instance. The combined forces of Azure Service Health and Azure Monitor enable you to set up alerts that notify you of shifts in the availability of your cloud resources. Speaking of Azure Monitor, you might be wondering what exactly is Azure Monitor. Azure Monitor is a platform for collecting data about resources, analyzing the data, visualizing information, and even taking actions based on the results. Azure Monitor can track Azure resources, on-premises resources, and even multi-cloud resources such as the virtual machines hosted by other cloud service providers. You can set up alerts to monitor logs and trigger specific log events, or configure them to track metrics and trigger when certain values are crossed. For example, you can set up an alert based on metric to notify you when the CPU load on a virtual machine exceeds 80%. Alert rules based on metrics provide near real-time notifications based on numerical values, while rules based on logs support complex data processing logic from multiple sources. Azure Monitor alerts use actions group to customize who needs to be notified and what action should be taken. An action group is simply a collection of notification and action settings that you associate with one or more alerts. Action groups are used in Azure Monitor, Azure Service Health, and Azure Advisor to send notification when alerts are triggered.
In our sixth session, we learned about management, compliance, and the Service Trust Portal. We explored resource deployment tools such as Portal, PowerShell, CLI, and Cloud Shell. We learned about Azure Arc and Azure Resource Manager capabilities. And we finished our training by describing monitoring tools such as Azure Advisor, Azure Service Health, and Azure Monitor. This concludes our sixth session.